Hi there, welcome to my channel Mandu to Fundu. In this video, I am going to discuss about the solution for merging intervals problem. Let's look at the problem description. We are given an array of intervals where each entry has the start and end time. We have to merge all the overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. So let's take a look at the example 1. So in this the interval has 1, 3, 2, 6, 8, 10 and 15, 18. So in these two intervals, if we see the end time of this interval is more than the starting time of the second interval, so they are overlapping. We have to merge these two. So it will become 1, 6, and then 6 and 8 are not overlapping, 10 and 15 are not overlapping. So these two will be added as it is. So finally we get 1, 6, 8, 10, 15, 18. These two intervals are considered overlapping because the first interval's ending time and the second interval's starting time are same. So we have to merge these two and return 1, 5. So the interval array's length is ranging from 1 to 10,000, and so the individual interval's length is 2, and then the start and end value is 0 to 10,000. They did not mention about whether the given input array is sorted or not. Let's see whether we have to consider that. In this input at least they are all sorted based on the starting time. Okay, I'm not sure whether that is the case for all the inputs. So we have the input intervals which has 4 intervals in it, and among that 2 intervals are overlapping, so we have to merge those two and return an array which has 3 intervals in it. Okay, so let's see how we can do that. There are two approaches. One is a brute force. First we added the first element in the interval to the new array and mark that as used. Then we try to find among these 3 elements which is closest. In this case the next element itself closest. So we, in case if this element is present at the end, then we have to traverse 3 items and find that closest item there. So likewise, once we pick that element, we mark that element as used. Then in the next iteration we start from this index 2 to the rest of the array and find the closest to this element, this interval. So likewise we keep repeating as many times as the rest of the size of the array. This approach leads us to an order of n square solution, and the space complexity is order of n because we create a hash map each element in the input array. Okay. So another approach is the 2-pointer approach. So in this first we sort the input array based on the start time. Okay, and we maintain a write pointer which points to the first element and the read pointer which points to the second element. Then we traverse from this rest of the array, from this second element all the way to the rest of the array. So when we traverse the array, each time we compare the element pointed by the read index with the element pointed by the write index and see, check whether they are overlapping. If so, update the end time of the element pointed by the write index. So in this case they are overlapping, so we update the end time 3 with the value 6. So this will be copied over here. Okay. Otherwise, if they are not matching, we simply increment the write index to point to the next element. For example, when the read index is here and this is not overlapping 6, so we simply advance the read pointer to the next, the write pointer to the next, and then we copy this number over here. So we repeat that process and then finally when we come out of the loop, then we return the subarray starting from index 0 to right idx plus 1. That array will be, so that array will contain non-overlapping intervals. Let's look at the flowchart. Input for this procedure is the intervals array, which contains an entry with start and end time of that interval. First we initialize the read and write indexes. The write index is initialized with 0 and read index is initialized with 1, and we initialize the count with number of elements in that input array. Then we check whether we processed all the elements in the array. If yes, we simply return the write idx plus 1. Otherwise, we check whether the element pointed by the read index and write index are overlapping. If so, we update the end time of the interval pointed by the write index with the value which is maximum among the end time of the element pointed by the write index and read index. Okay. So if there are no overlapping, we increment the write index and copy the data pointed by the read index into the position pointed by write idx. Then we increment the read index and repeat the loop until all the elements are processed. Once they are done, we come out of the loop and return the output will be the subarray that contains the elements from index 0 to write idx plus 1. Let's move on to coding. First I sort the input array based on the start time of each interval. So I call the sort slice function. First let me define the constant for the start and end time field. So we compare the start time of each interval. Then I initialize the count variable with the number of elements in the input array and initialize the write index with value 0. It points to the first element in the input array. Then I traverse the input array starting from the index 1. So the RIDX starts from 1 all the way to the end of the array. So in each iteration I check whether the interval pointed by the read index and the interval pointed by the write index are overlapping. So the write index end time is greater than or equal to read index's start time. That means there is an overlap. So in that case we have to pick up the maximum end time between those two elements and assign that to the end time of the interval pointed by the write index. Else I increment the write index and then I assign the value pointed by the read index into the location pointed by the write index. Once all the elements are processed, when we come out, I return the subarray starting from index 0 to write idx plus 1. Next, I am going to run the test cases. All the tests passed. So this is the case where the input is not in sorted order, the third case. Next, I am going to submit this program. Cool, this program is accepted. Next, I am going to do the code walkthrough with sample input. We are given this input array. Let's do the code walkthrough with this. So first we sort this input array based on the start time. Okay, so 1, 2, 8, 15. This array is already sorted, but there are some cases where it may be out of order. So once that is done, then initialize the count variable with the number of elements in the input array and initialize the write idx to 0 so that it points to the first element, and then the for loop starts processing from the element present at index 1, so that our idx is pointing to the index 1. So in the iteration 0, when we enter the loop, the read index is 1, write index is 0. Okay. So here we compare whether the interval overlaps. So the write idx end time and the read idx start time. Write idx end time and read idx start time. So they are overlapping. So we merge them together. That's why we see 1, 6. So basically this diagram depicts at the end of the iteration. Okay. Initially the array looks like this. The write idx point to the first element, 0th index, and the read idx points to the first index in the array. So we check whether they are overlapping. Yes, it is. So in that case, what we do, we pick up the maximum value among the end time between the elements pointed by write index and the read index. So in this case, 6 is the largest. So we pick that element and assign that as the end time for the element pointed by the write idx. That's what we are seeing here. Okay. And then when we at the end of the iteration, there is no change in the read idx or write idx because of the overlap. In the iteration 1, the read idx is incremented to 2. The write idx still points to the 0th index. Okay. So here we are checking whether the intervals overlapping. They are not. Okay. So 6, this is starting at 8, so there is a gap. So they are not overlapping. In this case, what we do, we increment the write idx so that this moves here, and we copy that. So that's why we see the 8, 10 in the index 1. Earlier it was 2, 6, but after the iteration 1, this is copied over here after incrementing this. This makes sense now, because at the end of the iteration, the write index points to 1. Okay, so we are overwriting that. Next, on the third iteration, the iteration 2, the read index will be 3 and the write idx is 1. But at the end of this, it will be like that, because this also, there is no overlap between 15 and 10. So we increment the right IDX and move to the position 2, and we assign the element pointed by the read IDX into the location pointed by right IDX. So this is copied over to this location. Okay, then reach the end of the array. So the loop breaks out, and when we come out, we return the intervals subarray starting from index 0 to widx plus 1. So which is basically this part of the array. Next I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. This has 4 elements, and let's see. So the time complexity for this sorting is order of n log n, and how many times this loop will execute? This will execute 1 less than the number of elements in the input array, so n minus 1 times. So for traversing it is order of n minus 1. So the total time complexity for this procedure is order of n log n plus order of n minus 1. We take the dominant term, so the time complexity is order of n log n. With respect to the space complexity, it is order of 1. We are not allocating any additional space during this processing. We use only few variables. So that's why the space complexity is order of 1. Thanks for watching this video. Have a great day.